In this video, I will compare the Smart EquiTest clinical system with data acquisition toolkit versus the Smart EquiTest clinical research system. And I'll conclude with frequently asked questions on the clinical research system. As a researcher, you have two options when considering the Neurocom balance system for research purposes. Option 1 is a Smart EquiTest clinical system with the add-on option of the Data Acquisition Toolkit software used for research, which is abbreviated as SMEQ with data. Option number 2 is a Smart EquiTest clinical research system, which is abbreviated as CRS. Let's review the differences. The force plate on the Smart EquiTest clinical system with the add-on Data Acquisition Toolkit software includes a standard Neurocom force plate with 5 load cells and measures FZ and shear forces, compared to the Smart EquiTest clinical research system with the Amti force plate that measures 2 independent 6 degrees of freedom measures on both left and right side for a total of 12 degrees of freedom. So let's compare the differences in the column with the SMEQ with data. Time duration is up to 190 seconds. The test trigger is with an easy click of a mouse. You cannot collect sync line status data. For data synchronization, it's sync out only. You cannot control all 3 motors independently or at the same time. And you cannot program motors for waveform. Also, you cannot post trial review graphs on the SMEQ with data. Now let's take a look at the CRS. For time duration, it's up to 600 seconds. The test trigger is with a click of a mouse, wait, or sync pulse. And yes, you can collect sync line status data. For synchronization, you can sync out and in using the master sync and/or the motor sync. You can also control all 3 motors independently and at the same time. For waveform capabilities, it supports trigonometric functions, user files, visuals, and Visual Basic Script. And last but not least, you can also create post-trial review graphs. Now let's move on to the frequently asked questions. What resources are available to researchers looking for education on the CRS system?
Quick access of the instructions for use is conveniently located on the main menu. All manuals are located in a desktop folder named Neurocom Product Documentation. Live WebEx online training can be arranged by request.
What type of information can you export from Statics Forceplates through the research module?
Under Export Options, the researcher selects the type of data to be exported and the units for each data type. Data types include load cell data, center of force, center of gravity, and head movement if paired with the head tracker.
Can the motor control test and the sensory organization test be recreated using the research module?
Yes, all protocols can be recreated using the research module, but please keep in mind, test reports are only available in the clinical module. For example, the 6 conditions of the sensory organization test, with 3 trials each, can be recreated with a sway gain set to 1.0 for both support and surround, following the sensory organization test parameters as described in the clinical operations guide. The 6 conditions of the motor control test, 3 trials each, can also be recreated following the motor control test parameters described in the Clinical Operations Guide. Note, the amplitude of the platform perturbation is scaled to the subject's height.
Is center of pressure data available for each clinical protocol?
All Balance Manager systems, including the Clinical Research System, center of pressure is equivalent to center of force. To clarify, pressure is the force exerted by a body in contact with a support surface divided by the area of contact. Hence, for a person standing on a support surface, the center of force and center of pressure are the same point.
The synchronization data from the dual top force plates to external sensors, can a timestamp be provided for the data logger in the research system?
At this time, no explicit timestamp is provided in the exported data. However, the research system firmware streams data, load cells, motor positions, etc., precisely every 10 milliseconds to the PC. The exported data points, DP, are effectively 1 for 10 milliseconds, 2 for 20 milliseconds, 100 for 1,000 milliseconds, and so on. Synchronization between the force plate and the external sensors can be achieved.
For providing biofeedback, is it possible to get more information on the structure of data expected via the Ethernet cable to monitor in a separate computer?
We have a sample Visual Basic program available by request for researchers wanting to write their own client monitor software. which includes data structure and communication scheme. The sample code shows how to request all available CRS data, 3 motor positions, all force moments from each force plate, sync status, etc. The CRS computer has dual network ports, one of which is available for external clients.
Is there any way to change the magnitude of the platform perturbation in real time?
No. Changes in the platform perturbation must be programmed. These changes cannot be adjusted or changed during the trial.
Does a change in time of prescribed points and change in angular position define the angular velocity of the platform?
Yes.
Which mode of operation enables a researcher to achieve the fastest possible speeds?
Both ramp and waveform, script and user files, can achieve fastest possible speeds.
What are the fastest possible speeds for ramp profiles?
The fastest speeds are 50 degrees per second for rotate, 15 centimeters per second for translate, and 15 degrees per second for visual.
Please describe the measurements provided by the CRS Amti force plate.
The CRS system data provides 2 sets of independent 6 degrees of freedom, DOF, measurements reporting forces Fx, Fy, Fz, and moments Mx, My, Mz. In contrast, the Smart EquiTest clinical system has 5 load cells.
If the Smart EquiTest clinical system with data acquisition toolkit added on, or the Smart EquiTest clinical research system is the right fit for you, please contact us today.